All right, we're going to work on one more example here. And it's going to be back in that physical application that's sort of recurring in this section, thinking about springs. So we're going to look at a damped driven spring. And you should be really familiar with this model by now. I've got mass a fifth times x double prime plus 1.2. 1.2 damping coefficient x prime plus 2, my spring coefficient x, equal to 5 cosine of 4t. And that's going to be how we're driving the spring. So usually we set this equal to 0. That's just natural spring behavior. Now we're saying we're kind of pushing on that spring in a cosine type way. So we like push, pull back, push, pull back. Again, remember when we do these applications, what we called y before is now x, and what we called x before is now t. And then another important step here is going to be to kind of note, way back when we introduced this method, we always assumed there was nothing attached to the y double prime. That's important for the way our formulas were set up. So we need to remember that if there's something attached to our highest derivative, we need to cancel it out. So we're going to multiply everything by 5, and our ODE is actually going to be x double prime plus 6x prime plus 10x equal to 25 cosine 4t. And then we're just going to note solutions to x double prime plus 6x prime plus 10x equal to 0 are x1 equal to e to the minus 3t cosine t, and x2 equal to e to the minus 3t sine of t. Those should look really familiar to you. You know how to solve for those and probably did quite a bit on your project. So our goal here is going to be to find our particular solution. So the particular solution, again, we could find using undetermined coefficients, but we're going to use this method instead. Variation of parameters tells us that it's going to be some particular solution x sub p is equal to u1 times x1 plus u2 x2. And we're going to use our formulas for u1 prime and u2 prime, but that means that we need to compute our derivatives. So we have x1 equal to e to the minus 3t cosine of t, and x2 equal to e to the minus 3t sine t. So we can compute our derivatives. X1 prime is going to have an e to the minus 3t on every term. And then we could imagine that we take the derivative of cosine t and get minus sine t. Or we could imagine that we took the derivative of e to the minus 3t, pulled out a minus 3, and kept our cosine the same. Similarly, x2 prime has derivative e to the minus 3t times derivative of sine, which just give us cosine of t, and derivative of e to the minus 3t is minus 3 times sine t. Then that quantity that appears in the formulas for u1 prime and u2 prime, our Wronskian, is x1, x2 prime minus x2, x1 prime. And so that's going to be a lot. E to the minus 3t cosine t times e to the minus 3t cosine t minus 3 sine t. I'm just copying things down from right here in the order I need. Minus e to the minus 3t sine t times e to the minus 3t times minus sine t minus 3 cosine t. Okay. My e to the minus 3t times e to the minus 3t in both of those terms is going to become an all over e to the minus 6t. And then I'm going to go ahead and pull everything together. So I have a cosine times cosine is cosine squared t minus 3 cosine t sine t from right here. And then I've got a minus sine t times minus sine t, so plus sine squared t. Then minus sine t times minus 3 cosine t, so plus 3 sine t cosine t. That's going to go right here. And then minus 3 cosine t sine t plus 3 sine t cosine t. Those will cancel out. And my cosine squared plus sine squared, hopefully you all remember, is just going to be 1. So this is just e to the minus 6t times 1 plus 0 is e to the minus 6t. Okay, so now we have to go ahead and calculate our u1 and u2 prime. So we're going to have u1 prime is our minus x2 times f over x1, x2 prime minus x2, x1 prime. So x2 was e to the minus 3t sine t, and our f was 25 cosine 4t, all over e to the minus 6t. Okay, and real quick, there's been like so much calculus and algebra in the middle here that it would have been so easy when I was looking for f to just go up to the original f I had. If I did that, everything would be off by a factor of 5. So this is the place where it matters that you pull the right f and you make sure that there's nothing on your leading coefficient when you calculate that f. Otherwise, your u1, u2 will be wrong. And my u2 is x1f over that same quantity, x1, x2 prime minus x2, x1 prime. So that's going to be e to the minus 3t cosine t times 25 cosine 4t all over e to the minus 6t. And when we go ahead and simplify this, just the exponents on top and bottom are going to cancel out. I've got u1 prime should be just e to the 3t, since I had minus 3 on bottom, minus 3 on top, minus 6 on bottom is the same as minus 3 times positive 6 on top. And then I've got, I guess that minus 25 should come out front, and then sine t cosine 4t and u2 prime equal to the positive 25 out front, e to the e to the plus 3t. Again, cosine t cosine 4t. Okay. So then we would go ahead and say u1 is the integral of u1 prime with respect to t, and u2 is the integral of u2 prime with respect to t. And I'm just going to tell you what that is because it's a messy trig integral, and this example is already very long. So minus 25 over 204 e to the 3t times minus 17 sine 3t plus 9 sine 5t plus 17 cosine 3t minus 15 cosine 5t. Again, this is the kind of thing that Symbol Lab or Wolfram Alpha would be nice for when you're actually doing your web work. 25 over 204 e to the 3t times 17 sine 3t plus 15 sine 5t plus 17 cosine 3t plus 9 cosine 5t. And when we go ahead and calculate xp equal to u1 x1 plus u2 x2, this is actually going to simplify a lot. I'm not going to show it to you, but it becomes minus 25 over 102 cosine 4t plus 50 over 51, I think, sine 4t. And the general solution will be x equal to c1 e to the minus 3t cosine t plus c2 e to the minus 3t sine t minus 25 over 102 cosine 4t plus 50 over 51 sine 4t. And there was a whole bunch of algebra and integration we skipped there, but problem already ran a minute over even skipping all that. So I'm going to stop here and then talk about the problem in the next video.